This is the second video on chapter 49, polar curves. And so now what we're going to do is we're going to sketch equations given the we're going to sketch a curve given the equation in polar coordinates. And so our first example was r equal to theta, where theta is greater than 0. Now if this were y equals x in rectangular coordinates, that would just be a line. But let's think about what's happening. As theta increases, r increases, and we have r equal to theta. So when theta is 0, r is 0. When theta is pi over 2, r is pi over 2. When theta is pi, r is pi. When theta is 3 pi over 2, r is 3 pi over 2. And when theta is pi, r is pi. And so as theta increases, r increases, and so it makes this figure here. Part B is a little more complicated. So for part B, what we're going to do, we have the polar curve y equals 4 sine theta. We're going to sketch the rectangular curve y equals 4 sine 2 theta first. So, and we know how to do this. This is just a trig function. And so this is the rectangular graph of y equals 4 sine of 2 theta. Now, here, we're going to draw the graph in polar coordinates. So, when theta is 0, r is 0. I should say, we want this to be r is 4 sine 2 theta. This is our polar curve. This is really what we want it to be. So r is 4 sine 2 theta. So when theta is 0, r is 0. So we start right here at the point 0, 0 in polar coordinates. Now, as theta increases from 0 to pi over 4, r increases from 0 to 4. And so this represents the point 4 pi over 4. And in polar coordinates, that is this point here. So we start here, and r increases to 4. As theta increases from 0 to pi over 4, r is also increasing. From pi over 4 to pi over 2, as theta goes from pi over 4 to pi over 2, r decreases from 4 back to 0. So we have this. As theta increases from pi over 2 to 3 pi over 4, r goes from 0 to negative 4. Now, the point 3 pi over 4, so 3 pi over 4 is this point right here. This is the point 3 pi over 4 in polar coordinates. But we don't want the point 3 pi over 4. We want the point negative 3 pi over 4. So we come over here to this point. Because now our r is negative. As theta increases from 3 pi over 4 to pi, r increases from negative 4 to 0. So r goes back to 0. As theta goes from pi to 5 pi over 4, r goes from 0 to 4. So the point 5 pi over 4 is right here. Then, as theta goes from 5 pi over 4 to 3 pi over 2, r goes from 4 to 0. So r comes back here. As theta goes from 3 pi over 2 to 7 pi over 4, r goes from 0 to negative 4. This is the point 7 pi over 4. So this is the point negative 7 pi over 4. And then as theta goes from 7 pi over 4 to 2 pi, r decreases back to 0. And so we have a 4-leaf rose. And you might ask, how would we have ever to known that this is a 4-leaf rose, that this equation gives us this graph? And the answer is with practice. So, for example, if I gave you this equation in rectangular coordinates, y equals x squared, or even a more complicated version of that. Either one of these, you know that this is a parabola. You know that this is a parabola just by looking at y equals x squared. You also know that this is a parabola. And that's just from experience. So the way that you would know that this equation is a 4-leaf rose, or at least a rose with some number of leaves, will be by experience.